In this video lesson, where we begin to learn about the concept of the mole, we're going to start by talking about particle types and the vocabulary, the terms that we use for the different kinds of particles. The three kinds of particles we're going to be referring to, they're either going to be atoms or molecules or formula units. So let's start by talking about how do you recognize the particles that are just atoms. Well, what you will do is, of course, you will look for a single element. So if we look up here in our word bank and we are trying to figure out which of these symbols up here represent elements and therefore the smallest particles are atoms, right? We're going to see that iron and helium and sodium. The smallest of those formulas exist as single atoms. So we'll cross those out of our word bank. So how do you recognize a molecule? A molecule is covalently bonded, and it will have all nonmetals. So it'll be covalently bonded, meaning it'll have, you're looking for all nonmetals. And it's either going to be, it can be a compound or a diatomic element. Okay, and then you will know that the smallest particle we are talking about are molecules. So we are looking for all nonmetal combinations or diatomic elements. So here we have CH4, carbon is a nonmetal, hydrogen is a nonmetal. Here we have CH and O, so C6H8O7. Magnesium is a metal, so that doesn't count here. C6H4. HCl, H is a nonmetal. Chlorine is a nonmetal. Those don't qualify. Okay, so here we have some diatomic elements. O2, Cl2, and then we have H2O. So we would refer to any one of these substances, their smallest particle is named molecules. So I'm going to cross them off the list, and we should hopefully find that the remaining particles are, the smallest particle of these substances are going to be called formula units. Right, so formula units are the smallest particles of ionic compounds. So you are looking for ionically bonded substances, which means you are looking for a metal and a nonmetal. Right, and so that should be the case. What's left? We have NaCl, we have MgSO4, we have AlNO3, Na3PO4, and that's it. Okay, so you're looking for metal, nonmetal combination. Metal, nonmetals. Metal, nonmetals. Metal, nonmetals. The only exception to the metal, nonmetal are anything that contains ammonium. So if you had like ammonium chloride, right? So here you've got, this is a positive cation and this is a negative cation. So in this case, even though we have all nonmetals, really this is an ionic compound. So this is like an exception to the metal nonmetal that we would still call a formula unit, because a formula unit is the smallest particle of any ionic compound. Anything with ammonium in it is also going to be considered a formula unit. All right, so now that we've got kind of the terminology of if you see atoms, molecules, or formula units, we are really just talking about, generically, we might refer to any one of those as a particle. Okay, so I just want you to get very comfortable with the fact that if I say particle, I could be specifically talking about atoms, I could be talking about molecules, or I could be talking about formula units, and the distinction there is what's in it, what kind of elements are in it. All right, so let's talk about counting these particles, right? The term particles is a generic term, just like we were talking about, and it is, if we're either talking about atoms or we are talking about molecules, or we are talking about formula units. Now, we're going to connect this to the mass, the average atomic mass that is on the periodic table. For example, when you look at carbon's atomic mass is 12.011. That has a unit of AMU, which of course stands for atomic mass unit. And 1 AMU, as you might recall, is the mass of 1 proton, which is the mass of 1 neutron. Okay. And as we see from this example of carbon from our periodic tables, a single carbon atom has an average mass of 12.011 AMU. But hopefully you can see this is going to be a very small mass, and it would be very impractical to work with 1 atom of carbon. So a more useful measure of mass for humans to work with is grams. Okay, and so let's try something. What if we weighed out 12.011, not AMUs, but this number of grams of carbon atoms on our scale. So here's a picture right here. We've got carbon atoms, and it says 12.00, pretty close to the 12.011. How many carbon atoms would there be? Well, it turns out that there are 6.02 times 10 to the 23 atoms in that mass. Well, that's interesting. It's a lot of atoms. What if we weighed out, let's take a look at helium. Helium has an average atomic mass of 4.00260. What if we weighed out 4.00 grams of helium atoms on our scale? How many atoms would that be? Well, the answer would be we would have 6.02 times 10 to the 23 atoms of helium. Does it work for, is this the same answer for any other element? The answer is yes. What if we weighed out 107.8 0.868, let's just write out the whole thing. What if we weighed out that many grams of silver atoms on our scale? How many atoms would there be? There would be 6.02 times 10 to the 23 atoms of silver. This number is referred to as 1 mole, right? 1 mole is equal to 6.02 times 10 to the 23 things, right? It's not specific to atoms. You should have already seen a video about the basic concept of a mole, where 1 mole is like a name for a very specific number, and that specific number is 6.02 times 10 to the 23. This number, you're going to see, is also commonly referred to as Avogadro's number. And we'll talk about him on another time. So what you have seen so far is that we can count atoms by weighing them. If we look at the mass on the periodic table and we weigh out that mass in grams on a scale, we will have 6.02 times 10 to the 23. So we don't have to count atoms one by one. We can't. That's not practical. They're too small. But we can know how many particles are in a substance so long as we know how heavy it is. This is going to be a concept that we will be relying on heavily as we move forward in this class. So buckle up. Let's go. We'll see you back in the classroom.